Okay, so lines and angles. Now, let me put this in a little context. What we want to talk about today are relationships that happen when lines intersect each other. Now, we spent a lot of time talking about that, and we had a couple pretty simple relationships that we dealt with in chapter 1. Okay, this is not a time for side conversations, so give you a second to kind of gather yourselves up here. Okay, so real quick, before we look at intersections, we got to review a couple topics. One of the things that this section does is it takes more of a three-dimensional approach to looking at parallel lines and perpendicular lines and parallel planes, stuff like that. So we already talked about parallel lines at the beginning of the year. And that was a piece of cake. We said parallel lines are like train tracks, right? Or the lines on the tiles on the ceiling, that kind of a thing. Lines that lie in the same plane and never intersect, right? So coplanar, same plane. I'm sorry? Not on a flat surface. Like on a sphere they do, like on a globe they do. But we're talking about the geometry of this class is plane geometry. So we're talking about geometry on a flat surface. And in that case, parallel lines never intersect. So coplanar never intersect. They have to be parallel. What about perpendicular? That definition's not up here, but somebody remind me what it means to be, okay, I see this, right? Perpendicular would be lines that intersect at what kind of angle? 90 degrees for right angle. Good. Okay? Parallel planes we talked about. Two planes that never intersect are parallel. So for example, the ceiling and the floor would be parallel planes, right? Here's a new one though. Skew lines. I don't think we've mentioned that word yet. Skew lines. Skew lines are lines that are neither parallel nor perpendicular. So they never intersect. I should say that. So they're lines that do not intersect and are not in the same plane. So give me an example of that. How could lines, give me an example of skew lines in the room. Somebody point to a couple lines that would be skew. Lines that are not parallel and never intersect. What do you think? Two lines in the room that are clearly not parallel but never cross each other. What do you think? Okay, so we could say, okay, or how about, so that, here's a line we can all see right here between these two walls. Right, there's a big line we can all see. And then how about the line, instead of the top of the desk, I'll make it a little bigger so we can all see it. How about right up here, where the far wall meets the ceiling? So we've got that line up there and that line over there. They never intersect, but clearly they're not parallel, right? So those are skew lines. Does that make sense? It will in a second if it doesn't. So let's look at this 3D view, and we're going to identify some of these kinds of lines. Now, in this 3D view here, this is a cube, three-dimensional. You have to kind of practice seeing this stuff just a little bit. So somebody name for me about what's the plane that represents the front face of that cube, the one that's closest to you guys. Okay, so AD, ADHE. We only need 3 points to define a plane. So we only pick 3 of those. We could say, for example, plane ADE would work. And on Moodle, I'd write it like this. You're going to have to do this. Plane A, D, H, for example, right? That would be the front of this thing. Everybody see that? Okay, what's the bottom plane of the cube? Okay, E, F, G, that would work. Points E, F, and G, that would define the bottom plane. Everybody see that? Okay. All right, so what I want from you next then is I want you to come up with, and raise your hands, come up with a line that's parallel to AB. So here's AB, the line AB, the line that goes through both points A and B. Parallel to that one and contains the point D. What's it going to be? CD, sure, right there, isn't it? Okay. Okay, those two are parallel. Okay, now what about the line that's perpendicular to AB that goes through D? Only one of those. AD, line AD, right? Okay, so it's right there. Those two meet at a right angle, right? Yeah, go ahead. Okay, how about, now there's a bunch of these, and this time I really want, don't say it out loud, raise your hand, I want to give people a chance to try this one. This time we want the line that travels through point D that is skewed to line AB. This one, HD is one, that works. Okay, everybody see that? There's a line through D that is not perpendicular, not parallel, but also does not intersect AB, so it's skewed, right? Okay, different ones. Back here, yes. ED works, yeah, right there. Those two lines also don't intersect, but they're not parallel. It's another one. DG would work too. I could do that one and that one. Make sense?
Yep.
Okay, so those are skewed. No big deal. Name the plane. There's only one of them.
Wait, what did DG intersect?
DG is skewed to AB.
The way you drew it.
Okay, well, yeah, it's because now made it look like they intersect. Okay, but look at it this way. AB this is a two-dimensional picture that represents a three-dimensional situation. So AB, imagine it's coming along. See what I'm saying? It's coming along that top edge, and DG is coming diagonally up over the top of this thing. So even though it might look like, if I draw these lines out like this, it might look like they're crossing. They're really not. Okay. Okay, so last issue then. Name the plane or planes. There's only one. So name the plane that contains point D and appears to be parallel to plane ABE. So first of all, which side of the cube, which face of the cube is ABE?
On the left.
Okay, or ABE, sorry. Yeah, that's going to be the left face over here, right? So there's ABE. What's going to be the plane that contains D that's parallel to that? Yeah, like DCG? Right there? Okay. Okay, so couple postulates. Really obvious ones, but they're really important. They come up a ton in geometry. The parallel postulate. Let's take a look at, just make sure it makes sense. If there is a line, so here's my line, L. Okay, forget about the red one for now. If there's a line and a point not on the line, so that's P. So we have line L and this exterior point P that's not on the line. Then there is exactly one line through the point P parallel to line L. There's only one of them. Any other line that we draw through point P is either going to be skew, or it's going to, if it's in the same plane, it's going to intersect line L, right? There's only one line I could draw through that point that's parallel to L. Okay. That's a postulate. It's something that's so basic we can't even prove it. We just know it has to be true. Okay. By the same token, the perpendicular postulate says if we take that same line L and the same exterior point P, there's also only one line through P that is perpendicular to L, that intersects line L at a right angle. All the other lines either don't intersect L, or they intersected at an angle that's not 90 degrees, right? There's the perpendicular postulate, okay? And we'll get back to that stuff in the future. Here's the last issue I want to get to. Okay, we're going to take the same idea that we talked about in chapter 1, and we're just going to make it a little more complicated. We're going to deal with intersections of 3 lines instead of 2 lines. Now, if we just look at 2 lines, this is a really simple issue, right? Okay, there we go. Okay, so if I just look at the intersection of 2 lines, like we did in chapter 1, 2 lines when they intersect always create 4 angles, right? Okay. Now we know how to describe those angles. Give me an example of these four angles here. Somebody raise your hand, please, and tell me an example of a pair of vertical angles.
1, 4.
Just raise your hand. Okay, yes, ma'am. 3 and 2. Good. What's another example? Yes, ma'am. 1 and 4. Okay, somebody give me an example of a linear pair. Angles that form a linear pair. Yes, sir.
1 and 2.
1 and 2. Another example. 3 and 4. Yes, good. Okay. So very simple stuff. Now, when we include another intersection in there, it introduces lots of other possibilities, and it gets maybe a little bit more, a little more complicated. Okay, so what do we do with this? If I want to be able to identify angle relationships here with all 8 of these angles, I have to divide up the angles into 2 categories. I have to divide the angles into angles on the same side of the transversal and angles on opposite sides of the transversal. And what do I mean by transversal? The transverse means across. And so the transversal is the line that's cutting through the other 2 lines. Right? So in this case, the red line is the transversal. So we'd say that all of the angles on the same side over here, for example, angles 3 and angles 5, because they're on the same side of the transversal, we call those consecutive angles. Okay, those are consecutive angles because they're on the same side. Okay, we also categorize the angles based on whether they are between the 2 lines or outside the 2 lines. In this case, because those 2 angles are in between, in this region in here, which we call the interior, we would call those consecutive interior angles, meaning though that pair of angles are on the same side of the transversal and they're sandwiched between the 2 lines. Okay? Now what happens if we take angles that are on opposite sides of the transversal? Like let's take, for example, angles 1 and 8. If they're on opposite sides of the transversal, we call those alternate angles. Okay? Alternate means opposite. Now this time, because they are outside of the 2 lines, we call them also, so these angles up here and these angles down here, we call exterior. Okay? So you see how that works? We've got whether or not they're on the same side of the transversal and whether or not they're both in between or both outside of the 2 lines. So how would we classify angles 1 and 8, do you suppose? Alternate exterior. That's it. Right? We call them alternate exterior. Okay? See how that works? Okay, the other thing we can do then is, aside from that, there are some cases where that scheme doesn't fit. Like, what about angles 1 and 5? Now, 1 and 5 are consecutive, but one of them is an exterior angle, angle 1, and one of them, angle 5, is an interior angle. So that doesn't fit. But 1 and 5 are still special angles. 1 and 5, would you agree that if I took this top line and I just twisted it to make it parallel to the bottom one and then I dragged it down so it overlapped with the bottom one perfectly, what angle would angle 1 become if I did that? Would it become 5? Because it's the upper left angle. If I took this top line and I kind of picked it up and set it down on the bottom line, then angle 1 would overlap perfectly with angle 5, wouldn't it? Mm-hmm. Okay, so for that reason, we say that they are corresponding angles because they correspond to each other when I overlap the 2 lines. Okay, make sense? There are some other angles that we don't really, some pairs that we don't really care about that don't fit either way, like 1 and 6. We don't really care about that relationship because they're not corresponding, but they're also, I can't define them the other way. They're alternate angles, but one of them is inside and one is outside, so 1 and 6 aren't special to us in any way. Right. So can you name for me then, given that scheme, for me, somebody, a pair of, raise your hand please, a pair of corresponding angles. Corresponding angles, yes sir.
2 and 6.
2 and 6, perfect. 2 and 6 are corresponding angles. Another pair of corresponding angles. Somebody else, yes ma'am. 4 and 8 are corresponding angles. What's another pair? Back here, yes, wait. 3 and 7. Okay, and then the last pair? What do you think? 1 and 5, okay? Somebody name for me a pair of consecutive interior angles. Yes, sir.
3 and 5.
3 and 5. What's another pair of consecutive interiors? Somebody over here. Somebody have it. Yes, yes, sir. 4 and 6, right? How about a pair of alternate interior angles? Alternate interior. Somebody who hasn't answered yet. Be brave. Yes, sir. 6 and 3. Good. What's another pair of alternate interiors? Yes, back here. Go. 4 and 5. How about a pair of consecutive exterior angles? Consecutive exterior. That sounds tricky. Yes, sir. Say it again. Yeah. Hold on. Did I say consecutive?
Yes.
Consecutive exterior. Almost. You got the exterior part right. No, not quite. 2 and 8. See why? 2 and 8. Because consecutive meaning they're on the same side, but exterior meaning they're outside of the two lines. So 2 and 8 would be an example of consecutive exterior. What's another example? 1 and 7. Good. What else have we got? Think. Alternate exterior. What would that be? Okay. 2 and 7. What's the other one? 1 and 8. Good. We got it. That's it. Oh, and then we did corresponding, right?
Yeah.
Okay. How would we classify? How would we classify 2 and 5? Trick question. You can't. They don't fit, right? 2 and 5 are nothing. Good. You guys got it. Excellent. Okay. That's it.
We're done?